This recording is from Mrs. Laura's IB Prep Algebra 2 class. Starting on Tuesday, we're going to be looking at quadratic functions. A quadratic function is any equation that has a power of 2. The highest power is 2. So if you look at the standard form, you can obviously see the x squared. In factored form, once you distribute the two parentheses, x times x will give you the x squared. And similar in vertex form, if you square that out, you'll get the x squared as well. So if you want to get the vocab written down, go ahead and pause. Otherwise, we will move on to the notes. So the first thing we're going to take a look at is graphing the quadratic function, the parent function of the quadratics. So if you want to get the topic and essential question for your notes, pause here. Otherwise, we're going to start graphing our y equals x squared function. So what we start with is the t-table. And I like to use at least 5 values for a quadratic equation. The graph of a quadratic equation is a parabola or the U-shape, so you need to know where the vertex is so that you can see points on both sides of the vertex. What we're going to be doing is learning how to graph the parent function and then either translating it or stretching or compressing it. So what we need to kind of memorize are our squares. So -2 squared, remember a negative times a negative is positive, so we get 4. -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So we plot those points on our graph. Connect them with a smooth curve. It's helpful if you hit all of the points. And there's our parabola. So again, what we're going to be doing is using this parent function and just shifting it or stretching and compressing it. So the first thing we're going to take a look at are translations of the quadratic function. So remember when we looked at translations of lines and we watched the clip from Batman and we talked about the asylum. Well, we have the same asylum going on with our quadratic function. So anything in the parentheses is inside the asylum. So this looks like a shift to the left because it's -3, but really it's a shift to the right. And then outside the asylum we have our +2. So the vertex of our shifted function is +3, +2. So when I'm graphing transformations, that's where I start. So I'm going to plot my vertex. And then what I do is I pretend that the vertex is really the origin, 0, 0. So from 0, 0, if I move right 1, 1 squared is 1. So I move right 1, up 1 from my vertex. 2 squared is 4. So from my vertex, I move right 2, up 4 to plot my next ordered pair. I do the same thing on the left-hand side. -1 squared is +1. So I move left 1, up 1. And -2 squared is +4. So I move left 2, up 4, and graph my parabola. So if you want to get that down, go ahead and pause. Otherwise, we'll move on to the next topic. Scale changes and reflections. So remember, again, in the asylum is the horizontal changes. So when we were in the asylum on the last example, we were moving right and left because that's how you shift along the x-axis. So this scale change will affect the horizontal factor versus outside the asylum it would be a vertical scale change. So what I'd like to do for my scale changes is kind of set up a t-table with those original parent function ordered pairs, transform them, and then graph instead of trying to keep track of everything in my head. So again, I'll remind you of the t-table for the parent function. We had -2, -1, 0, 1, 2 with our squared values. And then what's happening is we are, instead of stretching it horizontally by 2, we are compressing it horizontally by 2. Again, because of the asylum. It looks like we're stretching by 2, instead we're compressing. So what I'm going to do is I'm going to take all of my x values and multiply them by half. Again, the opposite or the reciprocal of what's in the parentheses. So the -2 becomes a -1. The -1 becomes a -1/2. 0 stays 0. 1 is 1/2. And 2 becomes 1. Because it's a horizontal stretch or a horizontal scale change, none of the y values are affected. So all of my y values remain the same. Once you have those transformed points, you go ahead and plot those on your graph. So I'm going to use a scale of 2 because I have some of those fractions. And then I'm going to go ahead and plot my points. So I've got -1, 4, -1/2, 1, 0, 0, 1/2, 1, and 1, 4. The last piece, we also have a negative sign. So what that does is it reflects it over the x-axis. It makes all of your y values opposite. This 3 is outside the asylum. It's not grouped together with the x, so that is a vertical stretch. So again, I'm going to start with my parent function values. And I'm going to transform them. This time I'm transforming the y values. I'm going to multiply all of my y values by -3. It's outside the asylum, so it acts normal. It does what you think it should. So all of my x values stay the same, and my y values are multiplied by -3. And then we go ahead and plot our points. I won't be able to fit my 2 -12 or my 2 +12 on the graph. It would be a little bit below. -1, -3, 0, 0, 1, -3, and then 2, -12. And that is the lesson that we will take a look at in class on Tuesday. I believe that is November 6th. We'll have your assignment, and then I will just help you go through the graphs and the transformations.